For over 8 decades, the aircraft carrier has stood as the undisputed monarch of the maritime domain. Each vessel, a sovereign territory displacing over 100,000 tons, commands a battle group encompassing thousands of personnel and an airwing capable of projecting power across an operational radius of 1.5 million square miles of ocean. Deep within the world's vast oceans, an unprecedented force is gradually taking shape. Beneath the seemingly endless expanse of blue, a testament to human engineering and strategic foresight is materializing. Its existence, veiled in profound secrecy and known exclusively to a select cadre, represents the apex of clandestine military development. This domain, meticulously funded by classified budgets, is where the United States Navy's most audacious and transformative vision is progressively transitioning from conceptualization to tangible reality. Central to this covert undertaking is a warship unlike any previously conceived. This next-generation aircraft carrier is poised to fundamentally redefine maritime power projection for the 21st century. For generations, the aircraft carrier has held its position as the undisputed sovereign of the seas, an unequivocal symbol of American naval ascendancy. From the venerable USS Enterprise of the Second World War, a vessel that reshaped naval engagements, to the formidable nuclear-powered supercarriers of the Nimitz and Ford classes, these colossal floating installations have formed the bedrock of U.S. naval strategy, enabling the pervasive projection of air power to virtually any global theater. However, as the global geopolitical landscape continues to evolve and novel threats invariably materialize, naval strategists have begun to conceptualize a carrier design that unequivocally transcends current operational parameters. This emerging class of warship is engineered not merely to dominate contemporary battlefields, but critically, to preempt and decisively address the emergent challenges of future conflicts. The very notion of concealing the construction of a vessel exceeding 300 meters in length and displacing over 100,000 tons might initially appear implausible. However, military history consistently demonstrates the efficacy of strategic deception and misdirection as integral components of warfare. Through an intricate framework of classified contracts, compartmentalized programs, and highly restricted access facilities, the naval authorities have evidently managed to envelop this undertaking in profound secrecy. Its existence, shielded from public scrutiny, is reportedly known only to a limited cadre of senior officials and trusted contractors. Despite the meticulous efforts to safeguard its design specifics and operational capabilities, a discernible pattern of emerging indicators has begun to surface. Defense analysts and industry observers have noted a significant escalation in research and development funding, specifically allocated to advanced naval technologies. This includes investment in areas such as electromagnetic launch systems, high-temperature superconductors, sophisticated artificial intelligence, and cutting-edge autonomous systems. Furthermore, patents lodged by prominent defense organizations provide glimpses into radical new hull configurations and propulsion methodologies. Compactly, an examination of redacted budget line items and cryptically phrased procurement requests strongly suggests the development of a vessel engineered to push the very boundaries of contemporary naval engineering and fundamental physics. Central to the developmental challenge of this next-generation Leviathan is the fundamental question of its propulsion. For many decades, nuclear fission power has represented the established paradigm for aircraft carriers, consistently delivering the effectively boundless operational range and sustained endurance deemed indispensable for global power projection. However, as naval strategists increasingly focus on future operational theaters, the exploration of significantly more advanced propulsion concepts has become a prominent area of research. This ambitious undertaking encompasses a diverse array of pioneering technologies.
Considerations include the integration of compact fusion reactors, which promise an extraordinary leap in energy density, and the deployment of high-temperature superconducting motors, engineered to provide exceptional power output with vastly reduced energy losses. Furthermore,
investigations extend to more esoteric advancements, such as magnetohydrodynamic drives. These systems, which propel vessels by utilizing electromagnetic fields to act upon a conductive fluid, eliminate the requirement for conventional mechanical components like propellers, offering a pathway to unprecedented stealth and efficiency. Similarly, plasma thrusters, leveraging ionized gas for propulsion, are being examined as another potential avenue for achieving remarkable velocities and operational efficiencies. The successful implementation of such state-of-the-art propulsion systems would not only confer unparalleled gains in speed and overall operational efficiency, but crucially, would also enable the adoption of radically different hull configurations. This liberation from the inherent architectural limitations imposed by traditional carrier designs promises to unlock an entirely new class of naval vessel with previously unattainable operational envelopes and strategic flexibility. Beyond the vessel's physical attributes, a profound reevaluation of air power deployment is evidently underway. Intelligence suggests a significant departure from conventional Airwing compositions, focusing instead on a thoroughly integrated unmanned Airwing. This strategic shift would see sophisticated autonomous aerial vehicles and advanced robotic platforms operating in a highly synergistic fashion alongside traditional piloted aircraft. While specific details remain under stringent classification, the implications for naval aviation are transformative. Such an integrated capability is projected to dramatically extend the carrier's operational reach and enhance its sustained presence across vast maritime theaters. Crucially, it would also serve to substantially reduce the direct exposure of human pilots to high-threat environments, thereby preserving invaluable human capital. Furthermore, the systematic integration of cutting-edge artificial intelligence and machine learning algorithms is anticipated to enable a level of operational synchronization and environmental comprehension that far surpasses the capabilities achievable through human operators alone. This confluence of advanced robotics and cognitive computing promises to unlock unprecedented tactical speed, precision, and resilience in complex multi-domain operations, fundamentally reshaping the dynamics of future aerial warfare. However, beyond its physical structure and its revolutionary Airwing, the truly transformative aspect of this naval asset resides in its projected function as the preeminent networked command hub for multi-domain operations. The prevailing geopolitical landscape, characterized by the proliferation of hypersonic weaponry, the pervasive threat of cyber warfare, and the strategic importance of space-based assets, renders the traditional perception of a carrier as a mere mobile airfield increasingly anachronistic. Instead, this forthcoming class of warship is being conceptualized to operate as the pivotal nexus within an extensive, interconnected architecture of sensors, platforms, and effectors. This sophisticated network would possess the inherent capability to seamlessly coordinate and direct military operations across the entire operational spectrum of conflict, from the depths of the ocean to the exosphere. Consider a hypothetical yet increasingly plausible operational scenario. This vessel, maintaining a covert posture deep within the Pacific theater, identifies an incoming hostile salvo of hypersonic projectiles. Within moments, its integral advanced artificial intelligence systems would initiate a rapid, comprehensive analysis of the detected threat. This would involve assessing vector, velocity, potential targets, and the most effective countermeasures. Concurrently, the AI would formulate and disseminate optimized response protocols and precise targeting data across its distributed network of allied assets. This network could encompass stealthy, uncrewed aerial vehicles performing reconnaissance,
autonomous undersea drones providing early warning or interdiction, orbiting surveillance satellites offering broad area situational awareness, and even land-based missile defense batteries.
The outcome of such an orchestrated response would be a meticulously coordinated, multi-layered defense system. This integrated approach would not only serve to neutralize the immediate inbound threat with unparalleled efficiency, but would also furnish strategic decision-makers with an extraordinary degree of situational awareness and granular control over the unfolding engagement. This represents a profound evolution in naval command and control, shifting from a hierarchical, human-centric model to a highly automated, AI-augmented system capable of processing vast quantities of data and executing complex maneuvers at machine speed, thereby conferring a decisive operational advantage in high-intensity, time-critical conflicts. The development of such an advanced capability is, by definition, fraught with formidable challenges, both technical and strategic. The integration of a multitude of disparate systems and platforms into a cohesive whole represents an engineering undertaking of monumental scale. This necessitates breakthroughs across numerous technological domains, range from advanced networking protocols and sophisticated data fusion algorithms to highly efficient power management and precise thermal control systems. Furthermore, the very concept of a carrier designed to orchestrate operations across multiple domains inevitably raises complex questions pertaining to command and control structures, the establishment of clear rules of engagement, and the inherent risks of escalation during periods of heightened international tension. However, for the strategists and engineers driving this initiative, such hurdles are perceived as an intrinsic component of progress. In an era characterized by intensifying great power competition and accelerated technological evolution, the United States, as a leading naval power, cannot afford to maintain a static posture. As nations like the People's Republic of China and the Russian Federation continue to invest heavily in advanced anti-access/area denial A2/AD capabilities, and develop sophisticated asymmetric warfare strategies, the imperative for the U.S. Navy to consistently innovate and adapt is paramount to preserving its strategic advantage. The conceptualization and development of a next-generation carrier transcends mere military expediency. It also reflects a consistent historical pattern within the United States of pioneering technological advancement and exploratory ambition. From the nation's inception, a discernible drive towards ingenuity and audacious undertakings has been a recurring theme. The project to deliver this covert carrier, despite its inherent complexity and the profound secrecy surrounding it, can be viewed as the latest manifestation of this persistent national characteristic. It stands as a testament to the inventive capacity and unwavering resolve that have frequently defined American technological pursuits. Consequently, as the Leviathan begins to coalesce in the shadows, its creators continue their work, acutely aware that their efforts are poised to influence the trajectory of naval power for generations to come. They are the inheritors of a distinguished legacy, one that extends back to the nascent days of carrier aviation itself. When figures such as Admiral William Moffett and Captain Joseph Reeves first recognized the transformative potential of air power at sea, these contemporary engineers and strategists are effectively the custodians of national security and prosperity, representing the technological vanguard of the American people in an increasingly unpredictable global environment. Therefore, as this formidable warship silently emerges, its operational personnel prepared for the challenges ahead, it is pertinent to acknowledge the sheer audacity and visionary foresight that brought it into being. Notwithstanding the veil of secrecy and the inherent mystery that envelops it, this project fundamentally embodies a nation's commitment to overcoming perceived limitations and pushing the boundaries of what is technologically feasible. It underscores the enduring connection between a nation and its defense forces,
a shared commitment to common objectives and collective sacrifice.
As long as this drive for innovation endures, and as long as there are those prepared to maintain vigilance and navigate the perils of the deep, the strategic impact of this vessel will persist. It is poised to become a tangible symbol of American ingenuity and resolve, a testament to the courage and dedication of all those involved in its creation and operation. The global maritime domain will undoubtedly register its presence, and potential adversaries will be compelled to acknowledge its strategic implications. This represents the future trajectory of American sea power, the cutting edge of a nation's determination to safeguard its interests and uphold its values. In the face of any challenge, any adversary, or any operational exigency, it is designed to stand as a formidable guardian of global stability and a potent instrument of deterrence. The ultimate ramifications of this extensive undertaking are unlikely to be fully comprehended for several decades. Much like the scientific and engineering endeavors that defined the Manhattan Project or the Apollo program, its influence will extend beyond the immediate military sphere, shaping the broader trajectory of human technological advancement. It stands as a profound testament to the collective capacity of a nation to marshal its considerable resources and unwavering resolve in pursuit of a singular, ambitious objective. This project embodies the enduring power of human ingenuity to conceptualize and realize new possibilities, serving as a benchmark for future technological leaps. Fundamentally, the narrative surrounding this carrier transcends a mere discussion of a naval vessel, a weapon system, or even a specific military strategy. It encapsulates the persistent drive of human enterprise to envision novel solutions and bring them into tangible existence. The strategic implications, as they gradually unfold, are predicted to recalibrate the global geopolitical calculus, introducing an asset designed to operate at the forefront of military evolution. Its operational deployment is poised to redefine established doctrines of naval power projection and multi-domain engagement, thereby influencing the strategic landscape for generations to come. The full extent of its impact, including potential unforeseen ramifications and technological spin-offs, remains an area of ongoing analysis and speculation within defense circles.